Data Skeptic is looking to bring on 2 new team members for our 2020 season. This role will be a little bit like a teaching assistant in a college course. Responsibilities will include reading a certain number of papers a month, being assigned, 1 or 2 that you'll be the presenter on to go deep into, a few writing assignments, as well as an on-air component. So we're looking for people who aren't just eager to learn and read the literature, but also have some on-air potential. Send resumes to jobs@dataskeptic.com. Get that to me before December 1st, 2019. We've got a few submissions already, thanks to everyone who sent. The window will close December 1st. Secondly, Los Angeles, California. We're going to be doing a live episode of Data Skeptic at PyData LA. Go to pydata.org/LA2019/schedule to see a detailed listing of the 3 days of events. Find me on there and see what else is going on. I hope to see you guys there. Come up and say hello. If you don't know, I actually have a special prize I give out to people who meet me at conferences and stuff. And that's the only way you can get it. So come find me. And I'll just go ahead and put this out there. LA data people, send me a resume. We're growing the team. You'll see some job postings on the website eventually, when we get around to fixing that up a little bit. But for now, I'm just throwing out fishing lines. Please send to jobs@dataskeptic.com. Eventually there'll be some automation there, but right now you're getting straight to me. I hope to see you guys at our live LA show at PyData 2019.
Hi, I'm Damian Brady. I am a cloud advocate for Microsoft. I talk a lot about DevOps and machine learning ops lately as well. Been getting into that. I've been a developer for about 20 years or so now, paid developer. So yeah, I've seen a whole bunch of different industries and different types of applications, but ML is still a newish thing to me, I guess. Yeah.
Yeah. In your career, you've seen, or at least in my opinion, in that time period, a significant maturity in software engineering. It went from this Wild West to very nice version control that people like instead of hating, and collaboration and CI/CD, and it's science fiction compared to how things were developed in the 90s.
Oh, completely, yeah.
I feel like maybe we're on the same but an earlier path with machine learning. How do you look at it?
Yeah, I think that's a great way of putting it. I remember I was talking to somebody about this yesterday, that I remember when I was at university, we didn't even have a source control subject. Like none of our stuff was in source control. Which now just seems insane.
Right.
You wouldn't do any of this stuff without source control. And for me, I wouldn't try to develop software without also having a CI build and continuous delivery, at least, maybe not continuous deployment. But, this whole process of building this stuff together, merge strategies, pull requests, all that kind of stuff is just, par for the course now. And ML, I think, is this area where all of the projects could probably benefit from those similar ideas to a great extent, but it's not quite there yet. I think the process of actually delivering machine learned models into production systems is still a little bit similar to software development was a number of years ago.
Mm-hmm. So let's maybe put our thoughts in the shoes of a young developer, young machine learning engineer who has been working very hard in a Jupyter notebook off some CSV, and now they've come up with some model and they think it's done. They're in for a big surprise here. What kind of things don't they know yet?
Well, the first thing I'd say, I actually kind of went down a rabbit hole with source control for Jupyter notebooks. The first thing I learned, and remember this is ML was a relatively new thing for me. The first thing I learned is that Jupyter notebooks contain not just the code that you run, but also the output of that code and things like what order the cells will run in and all that kind of stuff as well, which kind of goes against the way that software development works, where what you put in source control is not the output, you put in the input, you put the code in source control. So just adding a Jupyter notebook into source control means that you're adding different versions of the file when different people run it on their local machines, and then you get merge conflicts that way. It's difficult to work with in source control in general. There are a few techniques you can use to get around that, but in general, I like the idea of working in an exploratory fashion in a Jupyter notebook, but using that as your kind of day-to-day, exploring the data, working out what you can do with that data as that tool. But then anything you want to collaborate with the rest of your team goes in, if you're writing Python, just goes in a pure Python file. And you can quite easily just export a Jupyter notebook to a Python file. I think it's NB convert or... Yeah.
A little messy, but it works.
Yeah, it does a good enough job. I think I've got a blog post in the works actually about doing that as an automated strategy as a client-side Git hook. So when you actually make a change to a Jupyter notebook, you just commit that change, and that Git hook will pull the output out, put it into an HTML file in a different folder. So you can actually look at that output later on if you want, but then strip down the notebook and also create a Python file in another folder as well. So you can automate that later on.
Oh,
with that
neat.
pipeline.
It's sort of like a very, very high-level compiler almost.
Almost, yeah.
The data scientists get to write their notebooks, and then the software engineers get something that looks like Python, and or is Python, but has some weird comments in it, but ignore those and we're good to go.
Exactly right. And I guess the other advantage that gives you is it gives you a Python file which, when somebody makes a change to a notebook and commits that code, you can just run that Python file in an environment. You don't need to know about Jupyter. You don't need to know about the order of cells and things like that. It's just running Python, which any CI system can do, or any build server can do. Actually training the model, though, is kind of going to be a bit different, I guess.
Yeah. So that doesn't, in my mind, have a great analogy to software, because compilation is compilation. That's the closest thing, but it's very different.
Yeah.
How do you look at the model process in it?
Yeah, so because I'm coming at it from a software development background, I do kind of see a model, like a training run, as equivalent to a build. But there are obvious differences, right? A long-running build for a piece of software might take, an hour or something, if it's a long-running build.
Yeah.
A long-running model training process, you might be talking weeks, months, like huge amounts of time, and very CPU intensive and computationally intensive, or GPU intensive, but very data intensive as well. Like, there's a lot of I/O going on to do that training in a lot of cases, right? This doesn't really happen with the build, which means just taking a build server and saying, okay, now just run this Python that does the training, and here's your petabytes of data over there.
Right.
It doesn't really line up particularly well. So I'd say that in a couple of respects. One is that, long-running tasks aren't managed terribly well by CI servers. So having separate tooling and separate products that manage those life cycles a little bit better is an important thing as well. The other part of it is that the data itself and the code itself, it's very easy to version code in source control, but versioning data is a whole different story.
Yeah.
And it's still important. Like, when you get a predictive model out the other end, you want to know what data was used to contribute to that model. And in some cases, in some countries as well, it's 100% vital. You can trace, what was required to get this model out.
Yeah.
Like, am I using, there's discussions about GDPR as well. Like,
Sure.
Was somebody's personal information used to produce this model? And if they ask you to remove that personal information from your system, do you have to retrain the model? And
that's a very interesting question.
And I don't know, is the short answer. I think that's one of those things where you let the lawyers decide how they want to interpret it.
There is some amount of information content in that record that is perhaps represented in the model, but at the same time, a model where taking out one data point drastically changes it is not much of a model.
Yeah, that's a very good point, I guess, yeah. But legally you may be required to do it anyway.
True, the letter of the law.
And whether you are or not, whether you decide you are or not, knowing that data was in there and contributed to that end result is probably important as well. Yeah. Which means at some point you've got to be able to say, from this model, what was the code that was used to produce the model? What was the data that was in that? And, can I reproduce it later on if I want to? With code, with building an application, that's relatively simple. Most of our tooling does that quite well. We have our build artifacts that we deploy. We can trace that back to the changes that were made in our repository. And then from there, you can look at, ideally, if you've got the right tooling, the work items or the tasks that the developers were doing, those ideas all the way through to what's running in production. With machine learning, that model that's in production, it's a little bit harder to get back to, here was the data that was used. I think there's no silver bullet for that. I think a lot of that is it's a data engineering problem.
I see a lot of people reinventing the wheel here.
Yeah.
And myself included. I built one system where we materialized to S3 and we materialized to blob storage, and that worked out. Another case, we stored the original query.
Yep.
Even though that, you'd also have to have a snapshot of the database, technically, was sort of worked well enough in that case.
Yep.
What other use cases, if any, do you see?
I've seen a few people do things like periodic extracts and just realize that, at a particular point, the training data is going to be out of date by X period of time. And that's reasonable, I guess, to a certain size of data. If you're talking about petabytes and you want to take a snapshot every week, that's a tough problem. Some other ones around data engineering as well could be things like, I can't remember the exact term for it now, but forward-only data. So you're never writing over the top of a record. You're writing a new version of that record and you're timestamping it, which means you can just keep writing data. But at any point, if you need to go back in time and say, what was the data at this point where we did that training run, Like, this is what that data looked like because it's all there.
Yeah.
That's, I guess, probably not always possible.
If you can have immutability, go for it.
Yeah, that's the word I was looking for, immutability. Yeah, so if you can have that, that does make that problem a little bit more achievable. And then there's other things like, reference data that doesn't change very often. You probably don't need to snapshot that as much. But that's a lot of work kind of up front, like well ahead of the time.
Yeah.
And it also might mean changing other applications that have been there for a very long time just to get a result for a new application in a reasonable, traceable way. So it's important. It's just a difficult problem to solve, I think.
Yeah. There's also so many different ways in which people do data science. R and Python, very similar tools, but at the same time also very different.
Yep.
And I see people in both of those two worlds getting stuck at one stage. They do a lot of good work and they come up with a model, and to take the Python case, then they know they can pickle it. And then there's kind of this what's next phase.
Yeah.
And again, lots of reinventing the wheel.
Yeah.
What are some of the maybe more mature options that are emerging?
Yeah, so depending on what type of model you've produced as well, there are a few different ways. I know the Azure Machine Learning team is looking very much at Dockerizing those containers and then just providing endpoints inside that container. So you get a model like a TensorFlow model, for example, and they would use something like TF-Serve, and then they would wrap it in a Docker container and then deploy that to Azure Container Instance or Azure Kubernetes Service or something like that. And that can be done in Azure Machine Learning with like a single API call. You basically say, there's my model, Dockerize it, put it in a container, and now it's an accessible endpoint. So you could use that in your application. Generally, we're talking about operationalizing the thing, right?
Exactly.
And it depends on your use case. Like, that's great for web applications. It means you can scale really well. If you deploy it to an AKS cluster and it performs reasonably well, you can scale that up and down really, really quickly, and that works. But if you wanted to embed it in an application, then you probably want that model in a format that you can use in your application. I like to think of that, in that case, a bit more as a resource, like a dependency, or an artifact, a library, something along those lines. So you have this whole build process that has produced this artifact, which is a predictive model, or which is an ML model. That ML model is essentially just an object or a dependency that an application can use. And it should be idempotent as well. Yeah. Or it should be immutable as well, so that if you deploy that to a particular mobile application, for example, like, you can keep deploying that one file to different versions of that mobile application, and you're going to get the same model, right? But it's this packageable, portable kind of thing that you can keep using. I know Microsoft's put a bit of work into Onyx, I think, is another format as well. And I think a lot of the AutoML stuff that's in Azure Machine Learning, I'm fairly sure that spits out an Onyx file, but don't quote me on that. And then that is a cross-platform, like the Onyx runtime, I think, is now open source.
I believe so, yeah.
Yeah, so the idea there was to have, like, here is a model format that anybody can use for anything they want.
Totally interchangeable.
Yeah. So having a portable artifact as the result, just the same as you would have a portable, like, executable file as the end of your software development. Like, that's a thing that you have, that you've produced, that you can reuse in different places.
Yeah. So a lot has gone into the versioning of that executable, even if it's not quite an executable in the cloud anymore. It's other things. There's still a strong analogy there. How are people tackling this problem of change management for models?
Yeah, that's a tricky one, I guess. So you mean change management of different versions of, like, rolling out different versions of models?
Yeah, so let's jump down the road a few paces from our setup situation. Now we've got a model in production and 6 months more data, so we retrain it and we believe the new model is better for some reason. We'd like to switch it over, but that should be done with caution.
Yeah, definitely. And I think this is where kind of you get the best parallels with DevOps. With DevOps, we have, traditionally you would have your artifact, you'd have your version of your application, and then there are a whole lot of techniques you can take into account when you actually want to deploy that out. You don't want to just write over the top of production without testing it. So there's obviously the testing pre-production stuff. But then there's also techniques like canary deployments. So roll it out to a subset of your users, see if it actually performs. Maybe even A/B testing. So have both versions, the old one and the new one of your model, in production at the same time. And then you monitor metrics that determine whether, and ideally it should be, is this giving me or giving my users better value in production? However you define value.
Yeah.
And again, kind of recommendations engines are a great way of telling this story of, let's put two versions of the recommendations engine in production and we'll A/B test them and we'll see what click-throughs we get on each of these versions. And so if our new one is not performing as well, then we roll it back. We just, A wins and B goes away.
Right.
You can also use techniques, especially if it's wrapped in applications like feature flags. So if your application is calling one or two different versions of the predictive model, you might be calling the one that already exists if the flag is turned off, and then the new one if the flag's turned on. That way you can deploy it slowly out to your production environment, and if you find it's not performing, you just turn the flag off again. And you don't need a redeployment, you don't need a retraining, you don't need to write anything over the top. And these are all things that we do with software development, right?
Yeah.
I think they can absolutely apply to machine learning as well, those same kinds of techniques. I mean, we're trying to deliver better value to production, and so determining whether what we've got in production provides better value and doing that in a safe way is, absolutely applicable, I think.
So I think in my mind, the machine learning problem's a little harder because in my experience with software, at the moment of release, you pretty much know if the release was botched.
Yeah.
There's some chart somewhere that either drops or jumps to 100%, and it's rollback time, right?
Yep.
A machine learning model could, start making weaker recommendations, and it's harder to know you have a drop-off, or monthly active users decline slowly because it's really an ecosystem that's being changed.
Yeah, I think that's totally fair. I think rather than, hey, we wrote this code and we went to production and it died, therefore we know that this was a bad deployment. The analogy doesn't fit so well with that. It fits a little bit more with, hey, we moved this menu item slightly, or we put it under a different one. Are people still using this feature as much? And you don't really get, you can't see that immediately. You might see that over a period of time. I know, for example, the Azure DevOps team, so the team that writes Azure DevOps itself, they have a definition of done, which is good software development strategy, where you say this feature is complete when we've done these things, or this work that we're doing is complete when we've done these things. And usually it's things like all the code's written, we've got tests around it, all those tests pass, and maybe it's actually deployed to production. They take it one step further and say, there's also got to be telemetry in production that tells us whether the reason we wrote this feature is a valid hypothesis. It's like experiment-driven development, hypothesis-driven development. So what that means is you don't really know whether a feature is done until a period of time afterwards when you've been monitoring how people are using it. So they will monitor things like how many people started using this feature and then stopped using the feature, because that's a pretty good indicator that it's not performing well, it's not providing value. And I think those parallels are a little bit closer, where you're deploying this predictive model, like this recommendations engine out. You're not going to know immediately whether it's better or not. But if you do an A/B test for a period of time, you can compare those two models against each other. Or even if you deploy it all the way out to production, you have your historical data about how people are using it, and then your current data. Are we doing better or not? Then maybe we roll it back a little bit. I think that does seem to be pretty much every problem in machine learning, rather than just the edge cases like it is in software development.
Today, 43% of college grads work underpaying jobs that don't require a degree, while 200,000 tech jobs go unfilled in high-growth industries across the U.S., according to research by Burning Gas Technologies and Strata Education Network. Flatiron School can give you the skills to build a career you love. At Flatiron School, you'll learn data science from seasoned instructors and study a carefully structured curriculum designed to introduce you to the math, programming, algorithms, and data engineering skills to prepare you for a career as a professional data scientist. Your education will be paired with career support from our best-in-class career services. You'll meet weekly with a dedicated career coach on resume review, interview prep, and build an employer network to help you land the job you want. Complete details are available at flatironschool.com/terms. Learn more at flatironschool.com/dataskeptic.
A lot of times I find people arrive at the model, they get it deployed, and they might be done. Maybe that's all the company needs. It's an image recognition system that finds defects in the product, and the variety of defects doesn't change. Never need to update that. But other systems, and maybe the stock market would be the worst. You probably need constant readoption.
Yeah.
How do people deal with those challenges in your experience?
I think the less continuous the improvements that you need to do. So if you have that project where the output is, this thing, you will never need to use it again. And especially other data science projects, which aren't necessarily machine learning. There might be things like, give us a a high-level thing of where we should focus our attention for the next 12 months. And then that is one report, and you don't look at it again for 12 months. You don't do that again for 12 months. Having a full CI/CD pipeline for that is not useful.
Sure.
I guess unless you do it every single year and, you find that valuable. So those projects, I think, the more separate they are from continuous improvement, the more separate they'll be from the applications they run in terms of how those pipeline cadences go. The application that uses those models might be continuously improved, but the model itself is not. So you would probably have those as two separate pipelines. So the model training and the production of whatever the output from that data science project is one thing that runs once you get this output, and that is an artifact that your application uses, continuously. The application might continuously update, but the model is just this artifact that you use. And then maybe 12 months later, you have a new version, so you start using that when you're building your application. If it's more continuous and more kind of embedded in the application and uses usage data from the application and so on, then I think the data science teams and the development teams need to work much closer together. And your DevOps people, your operations team, everybody. Frankly, everybody, marketing, product management, all that kind of stuff. If they're all in the same room at this point, then that means that you can kind of align those cadences and say, well, look, we're releasing this new feature. We think we need to put effort into this part of that model. Let's align the process of building these applications, build them together, and then embed the model in the application and actually have that synchronization between the teams. I think it's more important then, I guess, if they're continually updated as well.
Yeah. All that, even if you have a beautiful CI/CD pipeline set up, there's still work to push releases through and verify things and all that. So once you've got your model out in production, you sometimes have a tough challenge. Should I go and invest in that update? Should we do this ceremony quarterly? And of course, just like the use cases earlier, the image recognition thing, pretty clear, stock market, other cases.
Yep.
Different businesses evolve in different ways. Different problems may or may not kind of reset themselves from time to time.
Absolutely.
Are there any techniques you're aware of for tackling situations like that?
Yeah, so there are a few techniques. One of them that I know the Azure Machine Learning team is working on, and they've got some of it working at the moment. I think there's more and more to come, is the idea of data drift. So at a high level, if you set up a machine learning pipeline that uses a known data set, and that data set might obviously change, you have more data added and so on. But if you train based on that known data set, and that is your training data set, you can produce a model that comes out the other end, and you know that model was trained on that known data set.
Right.
When that model is in production, you can either, whenever somebody makes a request to that model, you can save that request data to another known data set, which is your production or your inferencing data set. Or you can dump stuff in the inferencing data set if it's batch jobs and then run them through the model and so on. And then periodically, you compare the training data set with the inferencing data set. And it will look for skew of that data or drift of that data. And if it reaches a certain threshold, it will automatically kick off that retraining pipeline using the data that you've been using in production. As well as that, some of the really cool things they're working on is they're looking at when that model gets produced at the other end, as a result of that, actually compare that model and its performance against what's currently in production and determine that, when we did run this training with what's in production, it actually is performing better with that data that we got in production. So it's not just assuming, hey, if we trained it on production data, it's going to do better. It's testing that before it does any kind of deployment as well. Some of the things that are planned, they're doing different levels of training runs as well. So whether you just retune your hyperparameters or whether you retrain using the same algorithms on the new data, or whether you just do an entirely new AutoML training run that reselects the algorithm based on the data that you've got as well and looks at the performance of these different algorithms against each other and does a complete new generation of a model. All of these things at different levels to give you something that you can be relatively sure, based on what we've seen in production, this does perform better. Let's slowly roll it out. So some really cool stuff with that, but actually comparing what's in production with what you trained on is at a high level kind of that technique.
Very neat.
Yeah.
Are there any rules of thumb for how you look at that? I should put 5% of canary traffic in, or how long to wait? I always hear you should wait at least a week because there could be a weekly seasonal effect, which always sounds reasonable. I don't know.
Yeah, I think it depends on the usage and the type of model as well.
Sure.
But I've heard of people actually having a lot of success in some cases, especially retail and stuff, with using models that have like reinforcement loops and things like that based on previous like time series data and all that kind of stuff. And so that's a very specific kind of scenario. If your loops in your model graph are kind of time series based and you do it based on a week ago, then you obviously need to leave it in for a week at least before you're going to get any real performance impact. But then similarly, if you have a recommendations engine and you are adding new products every single day, then matching it with the data that comes in is probably, at that same kind of cadence is probably important as well. Yeah, I think it depends very much on what that data looks like, I guess. Like if it's constantly changing data, like your example of stock market stuff, having a retraining strategy at a really tight cadence is probably important. Whereas if it's, the same product catalog for, 6 months and then maybe you update it, then you probably don't need to retrain every single day.
Yeah.
The other situation is really that real world pragmatic thing of, look, our training run takes a week and it costs $50,000. I'm not going to do that every week.
Which, by the way, that's a realistic number for some companies, right?
Yeah.
In case listeners don't know, that is...
Absolutely.
Yeah.
There was somebody I was speaking to in one of the Azure DevOps CAT teams who's been doing some work trying to work out pipelines for a company that's doing self-driving cars. I'll try to remember this. Each of their test cars generate something like 10 petabytes of data a day or 10 terabytes of data a day. Either way, it's enough it's enough that they can't just upload it over the wire. Yeah. So they have a physical box in the car collecting that data, and they will take that physical box and send that to Azure to the cloud. I think it's the Azure Box service.
Oh, yeah.
But they have them in the car. And so that data, just to do a retraining, that takes a very long time and a lot of compute. So they can't do that continuously. They can't do a daily run because it's too much data. They just cannot do it with a reasonable cost. So yeah, that is definitely a consideration. It might cost hundreds of thousands of dollars to do a training run. And you can get into techniques like doing training runs on what you think is a reasonable subset of that data just to prove out ideas. But again, nothing is the same as production really. So yeah, there's a few techniques like that, but ultimately, you're exactly right. It depends on that environment, depends on how the data is used and what that data looks like.
Yeah. When you were outlining drift, I want to see if there's a point of clarification I'd love to get. Is it the old model and new model and how their predictions might differ, or is it the old data and new data that's being compared?
It's kind of both. So it's the new data against the old model and the new model. So,
okay. I see.
So you can compare, if you use training data set and you continually use this, the training data set and your production data set, your production data set then just gets added to the training data set.
Sure.
And you can specify, I only care about
90
training.
days rolling or
Exactly,
whatever,
that kind of thing. But then that new model that's produced is compared against the old model that was there, but against the new data that you're getting. So I said it was both, it's not both. The old model and the new model compared against the new data to see how it's actually performing,
Yeah. So then I can say, well, they're different, but in either a very minor way or a significant way, and make a judgment call.
And there's nothing it's not necessarily true that, if you train on the new production data that you're going to get a more accurate model necessarily. I mean, you'd expect that it would, but maybe there's something about that new production data that means that the current techniques that you're using give you a very skewed result or something.
Oh, sure. Yeah. Could be marketing data and your competitors have changed their strategy. So you need to adapt as well.
Exactly right. Yeah.
I'd love if we could go through maybe a survey of the tooling that you see most people adopting. That notion of we're going to work in Terminal and Notepad or just a Jupyter notebook seems a little naive. How do larger scale projects get done?
So this is a little bit out of my wheelhouse, but what I've seen a lot is your typical tools like Jupyter Notebooks and RStudio are kind of the ones that the data scientists themselves are using. For the pipeline stuff, I have seen people just trying to kind of retrofit standard CI systems and then just deal with the whole long-running task idea. Kubeflow is actually quite a good one, which is a little bit more focused towards running training jobs using Kubernetes clusters and so on. So you can define a container that will run the different stages of your training pipeline, and then that can scale up and down in a cluster based on how much you can parallelize it and things like that.
Yeah.
So Kubeflow is one that I've seen a bit of. I'm obviously leaning towards Azure Machine Learning because it's one of the things that Microsoft especially is working on a lot.
For anyone not familiar with it, what is Azure Machine Learning?
Yeah, so it's a series of services basically that are really around that whole MLOps story. So there's a number of different parts to it. Ultimately, from an MLOps perspective, there's the concept of pipelines, which is almost like a workflow of different stages for a training pipeline. But then you have first-class citizens like a model, like a versioned model. And so you have a model repository. When you finished your training, you register a model, and that model can be a collection of files. It can be whatever you want, but this is version X of the model. And so that can be versioned and traced all the way back to the training run. You can run experiments. It can connect to all sorts of different data sets and data services as well. And that's kind of a first-class citizen as well. Here's a data set or here's a data service. Here are the experiments that ran. Nice UIs for seeing, the output and the process of those experiments and things like that. And then there's a few other things like resources that can be used, like Azure Compute and stuff like that. So, I don't want to run my training on my own machine. I don't want to pay for stupid amounts of hardware that sits there most of the time.
Right.
So you can have scalable compute that when you actually queue a training run, you can say, all right, use this compute cluster that I have. And it's smart enough as well to have scalability. So you can say the minimum number of nodes of this size is 1 or 0, and the maximum number is 10. So if you can parallelize your training run up to 10 different machines, then it will scale them up to 10 if you want to speed up that training. There's also things like low priority compute. So if it's not time sensitive, you can use lower priority compute, which means that we kind of use spare compute in the cloud, and that is much cheaper. We have those machines anyway. If they're not being used, then hey, maybe they can do your work for you, and it doesn't cost us a lot more, so it won't cost you much more.
The modern equivalent of the grad student midnight in the lab, right?
Exactly. Yeah, they're basically free. Yeah. So those kind of concepts all kind of paired together to give you the ability to define a training pipeline, the data that pipeline uses, the compute that you use to actually do that training, and then like the registered model, the Docker endpoints if you actually choose to deploy it that way, and the Kubernetes endpoints, and all of that stuff kind of in that one portal to allow you to, kind of manage your data science projects or your machine learning projects as well.
Gotcha.
Yeah.
On the model change management side, one problem I've had to tackle is, okay, we had a great model. Version 2 comes along, and part of what made it better is we came up with new features.
Yeah.
So now we have no longer this apples to apples rollout. It's extra challenging deployment.
Yeah, definitely. The actual model itself would just look different. Is that what you...
Probably, let's say it's a classifier, same output, but we went from 10 features to 15 features.
Right. So the input
has changed.
The input has changed, yeah. That can be a tricky one to kind of align them, because that's going to require changes to whatever application that actually...
the API and whatnot.
The API and all that kind of stuff, which obviously would change however you deploy that as well. So it'll change the application that calls that API, but also the API itself and what that looks like. And then we kind of get into other stuff that software development has seen for a while with API versioning. So you might need to keep both versions of that model in production at the same time, and then have some kind of way of versioning and mapping the request itself to the correct version of the API. You could probably also put a layer over the top of the new one that accepts the inputs from the old one.
Oh, that's
and feeds
interesting.
it through and
enriches it with the if it can.
Potentially, if that's going to work. It may not with that new model, or even contain have both models in that same container, and then dependent on the input, feed it through one model or the other.
Neat.
That stuff, obviously, in Azure Machine Learning, I don't think is out of the box.
Sure.
Definitely not. But you have those model artifacts yourself. You can pull them down, wrap them in your own container, put that kind of service over the front of them, and then use that technique to kind of feed it out. But it's not an apples to apples thing anymore, and you suddenly got to think about what the interface to that looks like.
Yeah. Well, we start our conversation about how much software engineering has changed and machine learning deployments on a similar path. Maybe to wind up, can you talk about N years in the future? Pick your favorite N. What will MLOps look like then?
My ideal scenario would be it looks very much like how DevOps works now, where it's difficult to imagine somebody, a software developer 30 years ago, for example, thinking too much about that entire pipeline and ownership of the code they're running in production with monitoring and telemetry that feeds back in and runs through that whole pipeline and stuff like that. At that point, they're writing their code works, they copy it to a machine, it goes into production.
And they're happy.
And they're happy.
They got that done.
Yeah, and I won't say that that's certainly not the case in every organization. Some places still work like that. I think I would love to see it if the machine learning projects that are out there and the data science projects that are out there in N years, I don't know, we can pick a number, but it'll be wrong. If that is a consideration of a data scientist's job as well, or a machine learning expert's job, is that they have that ownership of the code that they're writing now, the training techniques and the algorithms that they're using and all of that stuff, that ownership of that is in production. And they know that if it's not performing in production, they will see it because they have been part of that pipeline that runs all the way through to production. They can preempt the changes that are going to be needed, and that feedback loop of how is this performing in production, how is this providing value, is just part of their job. Like, they see that feedback loop, the stuff they care about is amplified, they know how to fix it, and it runs all the way through. I don't think the tooling's quite there yet. I think that'll require a few years of maturity, but yeah, I think the ideas have been around for a little while, and I think it's just a matter of everything catching up.
Yeah, just baking a little bit still. I agree. We're on a good trajectory, but exciting times in the future, I think.
Definitely.
Cool. Yeah. Well, to wind up, where can people follow you online?
So I'm on Twitter mainly, Damovisa, Damovisa. You can pretty much contact me anywhere with Damovisa, so damovisa.com, at Microsoft.com, however else. I think that's the best place to get hold of me.
Sounds good. Well, thank you so much for coming on.
Yeah, no problem. Thanks for having me.